The Trust-based Intrusion Detection and Prevention System is a SecOPERA offering for network hardening and is stored in the secure module pool in the form of a virtual machine. A developer can retrieve and install it in a network, monitoring its traffic and mitigating malicious actions. The main intrusion detection operation is performed with Snort, a popular and widely used open-source IDS with around 10,000 identification rules in its free edition. However, it may be challenging for a network administrator to manage a set of IDS within a large infrastructure and update periodically their rule sets. Moreover, modern persistent threats involve semantic attackers who try to alter the rules of such components and manipulate their behavior. Therefore, Snort is extended in order to utilize a trusted execution environment during its initialization and guarantee the integrity and confidentiality of the rule set, as well as to facilitate the administrator of several IDS instances. The SCONE solution is used as the T technology. IDS-T leverages trusted execution environments to enable secure handling of sensitive data and execution of code segments that require strict confidentiality. To utilize IDS-T, a container compatible with contemporary Intel processors is required, as it relies on the underlying Intel SGX technology. Intel SGX is a set of security-related instruction codes that enable application developers to create enclaves that are isolated regions of code and data, protecting sensitive computations from the rest of the system. IDS-T is based on the SCONE confidential computing technology that leverages Intel SGX to provide secure and confidential execution environments for applications. SCONE extends the capabilities of Intel SGX by providing an abstraction layer for easier enclave development. Thereupon, applications are packaged as secure containers, allowing easy deployment. IDS-T follows the sconification process to generate a confidential image. The Sconify image tool enables the transformation of a native container image into an encrypted SCONE-enabled image in a single step. This transformation, known as sconification, allows the sconified binary to execute its service within an SGX enclave using the SCONE runtime. Native image files are encrypted and their integrity protection is ensured. Access to them is provided only after attestation by the SCONE platform. A SCONE policy with sensible defaults is generated, incorporating native image environment variables and the working directory. This policy offers options for customization using additional features of the SCONE policy language, such as shared volumes, shared secrets, and injected files, ensuring restricted access to secured resources by the sconified binary. After the sconification of the initialization service, the data are encrypted, offering security at processing and at transit. Thereupon, the vanilla or the trust-based IDS can be integrated with an intrusion prevention system, offering a unified IDS-IPS solution. Thus, the firewall pfSense is used, a popular open-source IPS with both software and hardware device support. pfSense implements the core network segmentation and layering, while using Snort for further security evaluations. The two components can record their alerts, either in separate log files or in a unified one, further facilitating the network administrator and the collection of logs. As a final step, the user can choose actions that will be performed once a malicious action is detected, like the automatic blocking of the attacker. In this example, we use the trust-based IDS-IPS to harden a network component. At first, the component is mapped with the penetration testing toolkit. The IDS is initialized with a simple rule, which can identify the port scanning test of the SecOPERA Network Assessment Toolkit. The assessment starts. The IDS-IPS identifies the port scanning test as malicious activity and blocks the IP address of the SecOPERA platform. Therefore, the tests for DOS attacks, login cracking, and weak cryptography will fail. The result is that only the initial test was successful, and the component was hardened against the other tests. After the first run, We unblock the IP and restrict the protection mechanism to operate only as an IDS, thus not performing the hardening part. We execute, again, the assessment. Now, the traffic is not blocked and we observe that all tests are executed normally. All tests apart login cracking are successful, and the assessment reports the 3 related vulnerabilities. The incorporation of trust-based computation is further considered for the implementation of a next-generation IDS IPS. Here, the term trust is used in the sense of reputation-based algorithms that assess the behavior of networking entities. Therefore, instead of relying solely on predefined rules, behavioral patterns are also assessed by these heuristic solutions, identifying both attacks and anomalies. In the demo that follows, preliminary results are presented, with the defending side detecting a malicious or suspicious node that made excess use of resources within the current time window. The final goal is to incorporate such trust-based filters in the overall intrusion detection functionality of this hardening module.